Okay, in the last video we talked about this, how to find out the minimum value from a list of values, and we came up with an algorithm with name search min from list. Um, Here we have just made a little modification that rather than just returning the minimum value, we are also returning the position of the minimum value in the list. So for example, if the list is 17024, let's say, in 9, let's say that's our list. There are 7 numbers in the list. The minimum value is 0, so the minimum value itself is 0, but that appears in position 3. So when this procedure will end, the min value will contain 0, and the IDX, which is the position at which the minimum value was achieved, that will contain 3. So not only we are finding out the minimum value, but also we are finding out the position of the minimum value. This procedure or pseudocode actually describes a very simple concept. You consider the very first value as the minimum value and the very first position as a position of the minimum value, and then traverse the list element by element and see if you find any value that is smaller than the minimum value so far. If that is found, then replace your minimum value with the new minimum value and update your position number, and then keep on moving till the end of the list. So that's what that's the concept behind this algorithm searching minimum from the list. And to traverse the list, we use this loop, while loop. So next we solve a problem called sorting problem, very famous problem in computer science. So the problem really is, let's say we have a list, let's say 1 4 0 3 5 and 7, let's say, and the sorted order, the ascending sorted order, is the order in which the list is presented, so that the minimum value occurs first, then the second minimum, then the third minimum, and so on. So the sorted order for this particular list will be this. So this is the result. This should be the result of the sorting procedure. So let's see how can we solve this problem. We name this algorithm as sort list, and sort list contains this L. In this particular case, the L is simply this, and this N is the size of the list. In this particular case, the size of the list is 6, so 6. And right now L2 is empty, so although we have to populate L2, but right now it is empty. And counter, again, we initialize the counter with 1, and as long as the counter is smaller than 6, we keep on moving inside this this block. That's the body of the loop. So what we do is we pass the list and the size of the list, and we use the previous algorithm to find out the minimum from the list. So the minimum from the list will be found as 0, and its position will be found as 3. So min value will contain 0 and IDX will contain 3. Then what we do, we pick this minimum value and insert in L2. L2 was initially empty, so we insert in L2, we insert the minimum value, which is 0 so far. And then just in the original list L, we delete the value at the position index. So for example, the index position is 3, so we delete this particular value. So what we really do is we delete this value, we delete this particular value, and the list now becomes with size 1, 2, 3, 4, and 5. So what we do is we decrement the size with 1, and then we move on. Now the counter is 1 again. The n value, rather than 6, now the n value is 5. So 1 is smaller than 5, but the list has no 0 now in it because it was deleted. We search the minimum again, and we insert the minimum in the list. Now the minimum will be 1 in the new list, and we delete that value from the list, and we decrement the size. We keep on moving. Eventually the list L2 will be populated like so, and once this value of n becomes negative, which is -1, we will exit the loop and we will return the sorted list. But see how this sorting procedure actually uses the algorithm that we defined in our previous video. I'm not talking about that this kind of sorting algorithm is the most famous sorting algorithm. There are efficient algorithms, very great kind of algorithms for sorting. But the idea here is not to actually teach sorting. The idea here to actually come up with a pseudocode for this sorting problem, and also to show you how you can use this pseudocode, how you can use existing pseudocodes as instructions in other pseudocodes. So that's all about problem solving. If you really understand the selection, sort, and all that procedure really well, you're actually very good in problem solving, at least the problem solvings that we encounter in the logic that we need to solve different kind of problems in computer science. In the next video, I'm going to actually convert these pseudocodes to Python codes. What do you need to write this sort list procedure in actual Python programming language? And how will you change this search minimum from list in actual Python programming language? We will see the Python details bit by bit in detail, starting from right zero and ending at the very high details of Python. So in the next video, I will just be showing you how to convert this code. But when we will start learning Python, we will start from zero and we will see each and everything of Python in detail. So don't worry, in the next video, if you see things like lengthy codes in a very beginning, these are just because we have arrived at a pseudocode. It is I'm just want to show you how the pseudocodes, which are very expressible, how they can be easily converted to Python programming, just to show you the power of and simplicity of Python programming language. So in the next video, I'll be converting these pseudocodes to Python code, actual programming code. So hope to see you in the next video.